Okay, so the chemical reactions that you guys looked at in your lab. So we talked about synthesis reactions, we talked about decomposition reactions, we talked about single displacement and double displacement. Those are the ones you guys did with the magnesium. This is an example of a combustion reaction. So when you're looking at the general chemical equation for combustion, we're always looking at hydrocarbons in our case. So this is what the chemical formula, chemical reaction looks like for combustion. So this is the combustion of glucose. So this C6H12O6, that's a glucose molecule. Reacts with oxygens. This is the balanced chemical equation. So it produces carbon dioxide, water, and energy. What form of energy is released during a combustion reaction?
Hydrogen.
So,
thermal.
Yeah. Okay, so like when you're burning a fire, what kind of things do you see? Heat and light. Perfect. Beautiful. You got it. So this is the general formula for the combustion reaction. This is photosynthesis. We haven't looked at photosynthesis yet in our class. That's going to be in the biology unit. But what do you notice about the reactants and the products of the photosynthesis reaction compared to the combustion reaction?
It's like almost like a decomposition of a combustion.
Decomposition is not the right word. What do you mean?
It's like the opposite of it.
Right. So the reactants of the combustion reaction are the same as the products of the photosynthesis reaction. Same as the products of the combustion reaction are the same as the reactants for photosynthesis. So photosynthesis is what plants use to create food. So in a plant, it takes carbon dioxide from the air. It takes water, so you have to water your plants so they don't die. It takes energy. Where do plants get their energy from?
Sun.
From the sun, that's right. So those things react, and they produce, this is glucose again. Glucose is what plants use for food. When we eat plants, our cells ultimately get all of our energy from glucose. And they also release oxygen gas, which is where what we breathe. So these reactions are basically opposites of each other. And what's interesting is, who knows what a fossil fuel is? You've heard that term before. What's a fossil fuel?
It's any of the naturally occurring substances that can be combusted, produce energy, such as gasoline, petrol, coal, and natural gas.
Excellent. That's a beautiful answer. So a fossil fuel is basically a fossilized plant. So when a plant over time is subjected to heat and pressure, it becomes fossilized. That energy is never actually released. So it stores all this energy in the fossil form, and then when we harvest it and we burn it, that's where we can get our energy from to propel like our cars and to create like coal-fired power plants. Those are all examples of fossil fuels. So what I have here, I have some gummy candies. Well, we're going to use them. You don't want to eat these. They've been like touched in lab bench is pretty good. Can I get Katie? Can you tell me what the first ingredient of the gummy candies is?
Gummy.
Glucose syrup?
Okay, say it louder. Face the front.
Glucose syrup?
Glucose. Good. So we have our glucose molecule, C6H12O6. Here I have, it's okay, thank you, Katie, you can go sit down. Here I have some, this is potassium chlorate. I'm just going to put a bit of it in this test tube here.
Is it gonna like blow up like?
Yeah, just
blow up.
You're not gonna die.
It's fine. You'll be perfectly
You'll be
safe.
fine.
Okay, so I'm just putting a bit of it in this test tube. And the next thing I'm going to do is heat it up. So this is the first time I'm using the Bunsen burner, so let's just hope for the best.
Oh, okay.
This, am I allowed to, what's it called?
So cool.
Alright.
Gadoosh.
So I'm heating up.
Where's it going?
Yeah, I think so.
So I'm going to turn the lights off.
Like a shamboli. What? Like a
Mish, won't the test tube like break?
It won't break.
No,
It's made for
yeah.
withstanding heat. So what I'm doing now is I'm heating up this chemical and it's releasing oxygen gas. So oxygen gas is one of our reactants. There is oxygen in the air, but I want to have a lot of oxygen gas in this test tube so that the reaction occurs much more quickly. Great. I haven't done this myself, I've only ever seen it done.
Oh, snap.
Like fish is dangerous.
Potassium chlorate. Okay. I'm going to turn this off. So we have our hot potassium chlorate. Hopefully this will work.
Holy snap.
Later, Gummy. I'm a gummy man.
Find a place for me in hell.
Oh, there we go.
Oh, looks like fireworks. That's so sick.
Oh my god.
Looks like fireworks. Oh, yeah. No, come back. Come back.
It came back. Oh.
Burn another one, Miss Lee.
Hey.
Still going.
How much energy does the guy have?
Still going.
Yo, he's still holding on there.
Yo, that's it.
Poor gummy
Okay, so